And now for the last exercise of Flappy Bird. This is the exercise where we're going to talk about hit testing, which is determining if the bird is touching the obstacle or the ground. I'm going to set up an example here. It's not going to use the bird or the ground, but it will be very similar in some ways. Just to kind of show the principles and show you some debugging techniques that you can use while you're figuring this out. So I have here the standard game loop with the update, react, and draw functions, and the main P5 draw function calls the loop. This is just like the other exercises. And I have an object called thing, which will be similar to the bird, but not exactly the same. And on update, we update the thing, and on draw, we draw the thing. And the thing on update sets its X and Y position to where the mouse is. So these are variables provided by P5 that match the mouse position. I've also included a new property here called radius. And I use the radius to determine the width and height of the circle that we use to draw the thing. So the thing will be drawn at X and Y, which will always track the mouse and X and mouse Y position because of the update step. And it will use the radius, which is 10, times 2 to make a diameter, to make a circle of 20 by 20. So we can see this here. Every time the game loop runs, it moves the circle or the thing to match the mouse position. So the important thing about hit testing is that everything can be circumscribed by a box. This is a circle, but you could draw a box directly around it. And what we're going to do is compare boxes to determine if something's overlapping something else. So what's the box for this? Well, we can actually just go ahead and draw a box if we wanted to. We can do rect set x. We actually have to subtract the radius for this set x because circles draw from their center, but rectangles draw from the top left corner. So I'm going to subtract the radius to move the top left of the circle to the top left of the rectangle to the top left of the circle. The height and width of this box will be the same as the diameter. So now we have a box that fits the circle. And that's going to be what we're going to call a bounding box or a bounding rectangle. And what I want to do is make it so we can get the positions of the corners of this box into an object we can use for comparison. I'm going to make a new function on the thing called bounding rect. And this function is not going to take any arguments. It's just going to return one object. So I'm going to use the return keyword and then curly braces to say this is an object, which is, a value that has some properties. The properties are going to be top, bottom, left, and right. And they will match the top position, bottom position, left position, right position of the rectangle here. They actually match very well to the rectangle. So we can reuse the math that we did here for each of these properties. So this is the Y position of the rect, and that matches the top. So if we take the Y of our thing and subtract the radius, that'll be the top of the rectangle. The bottom is the Y plus the radius, because the circle is 20 pixels tall. And we draw from the center, so the Y plus 10 pixels is the bottom of the rectangle. Left is going to be the same as the X position here for the rectangle, so X minus 10 for the left edge of the circle, of the rectangle. And then we'll do the same math for the right side where we add this dot radius. So you don't have to format your code nice like this, but it certainly makes it easier to read. This problem is not so much about how many numbers or how difficult the math is. It's more about keeping things organized. So organizing all these numbers into one object with really easy to understand property names is a really big deal. What I'm going to do is actually set up another little function down here that's one of the P5 functions. And I'm going to create a variable to hold the things rect, do thing.bounding rect. So this is going to call that function, thing. This is going to call that function, and it's going to do all these calculations to create this object. And I'm going to store it in a variable just for a moment, and then I'm going to log this out to the console. And so I'm putting this in this function because whenever I hit the key, like spacebar, it'll print to the console. So I'm going to refresh my page over here. I'm going to hit space. And it prints everything out. It says the thing, and it prints the bounding rect object, which has top is 180, bottom is 200, left is 147, right is 167. You can see that these numbers are 20 pixels apart. These numbers are 20 pixels apart. That's because that's the size of the rectangle. I put the thing way over here. Those numbers are going to be pretty small. If I put it down here, they're going to be bigger, but they're always going to keep their relationship. 20 pixel difference between the top and bottom, 20 pixel difference between the left and the right. So we can always, at any point, get the top, bottom, left, and right edges of the bounding rectangle of our thing. So let's make something that we can collide against. I'm going to quickly create another thing. You can obviously pause the video to follow along with this. But I'm going to type this as quickly as I can. I'm going to make this a rectangle, so I'm going to give it a height and a width. I'm going to put it in the center of the screen by saying it's 80 pixels above the middle and it's 160 pixels tall. I'm going to give it an update function, just like the thing, but I'm not going to move it with the mouse. I'm just going to move its X position very, very slowly and have it loop the screen. So X is less than 0, let's put it on the right edge. This is similar to what we've done in other examples. And I'm just going to draw a rectangle for this one. And I'm setting up the numbers differently because it just works differently for rectangles and ellipses, mostly because rectangles start at the top left and ellipses start in the middle. So I have x, y, height, and width properties, and those map very well to the rect function. So I'm just going to pass those in just as they are. Then finally, to wire everything up, I need to call update in the update part of the game, and I need to call draw in the draw part of the game. All right, so I'm just going to stop here for a second. You can pause the video if you want to catch up. And you can pause the video here if you want to make sure that other thing is put in the update and draw functions. So let's see what this looks like. So now we have a very slowly moving rectangle, and we want to see if our thing is overlapping it. So it's overlapping if the right edge of the thing is to the right of the left edge of the box. I'm going to say that one more time because that's kind of complicated. The right edge of the thing is going to be to the right of the left edge of the box right now. So that just says that this number right here, right, is going to be greater than whatever number's here. Let's make a bounding rect for the other thing so that we can illustrate this a little bit more clearly. So make another function called bounding rect. It's again going to return a rectangle. or top, bottom, left, right. I'm going to copy paste this and just edit it because it's easier. And again, this is a rectangle, not a circle. We're trying to make a rectangle. What's really cool about this is we actually end up being able to do a lot of this very quickly. So top is this dot y, because that's where the top edge of the rectangle. The bottom is this dot y plus the height. The left is this dot x, because that's where we start. We start in the top left, so I can get rid of this part. And the right is this dot x plus the width. And let's go ahead and add another variable holding this bounding rect in our kind of debug area. And console.log out other thing and the other thing rect object. Oops, sorry, other thing rect dot bounding rect. So call the function properly, the method properly. So now, whoops, still have an issue here. Can I read bounding rect other? Oh, sorry, mislabeled. This is the other thing is the name of our object, so I was calling it wrong. And so now, when we hit any key, we get both sets of numbers. And so if we want to see over here, let's clear this and just make it one example. So this is overlapping because I hit the key press when I knew it was overlapping. So our left edge is 132 of the thing. That's not the edge I care about, actually. Our right edge is the one I care about. If our right edge is greater than the left edge of the other box, then we at least know that it's roughly over here on this side. So the right edge of our smaller object is 152, which is greater than the left edge of our larger object. We also knew that our top edge is less than our bottom edge. Top edge of the small object less than the bottom edge of the large object. The bottom edge of our small object is also greater than the top edge of our large object. So we can look at this here. So if our bottom edge of the small object is farther down than the top edge of our large object, then we're potentially going to be overlapping. So hopefully that's enough illustration. It's really hard to talk through all these numbers. Now I'm going to show you how to set up something in the React part of the game loop to do something here. So I'm going to create another function. I'm going to create another section in our code here called hit testing. I'm going to create a function. Thing over is, let's just see, thing is touching other thing. Just make it really explicitly named. And it's going to return true or false. It's going to return false by default because it's usually not touching. And how we wire this up is we say in our React function, if thing is touching other thing, we run the function, and this is going to give us back true or false. Then we want to do something. In this case, I'm just going to console log out just the word touching. But in Flappy Bird, this is where you would change the game state to lost. You could do something like this dot state equals lost. Should lost be a variable that you've already created. But this is just for debugging, so I'm going to do this. So by default, we're going to return false. But let's just test one edge here. And I'm going to use the code just by copying and pasting thing.rect and other thing.rect, .bounding rect, so that we have these two objects at our disposal. one object is going to have top, bottom, left, and right for the circle. The other one's going to have top, bottom, left, right for the larger obstacle object. So what was the first one we did? We said if the right edge of the small object is to the right of the left edge of the large object, then we might be touching. We're close to touching on one side. So the small object is thing.rect, and the right edge is .right, the property right property. And so if it's to the right, that means it's greater, because this is 0 and this is 320, so the numbers get greater as they go to the right. So if it's to the right, it's greater than, and so we can do if thing.right is greater than other thing.left, let's just return true here. So we're over here, and as we come closer, now we're touching and we're touching and we're continuing to touch. We're going to keep touching because we haven't started testing the other edges. But right now we're not touching, we're not touching, we're not touching, and now we're touching. So you can see right there, the edges overlap, and we just do the simple math, compare the two numbers. Now we want to stop touching when we get to here. So now we're dealing the left edge of the small object and the right edge of the large object. So we're only touching if we're between, the small object is between these two things. So we're going to basically do the same formula. We're just going to use the other edges, and we're going to use less than because it's whether it's to the left, and we're going to use the right edge of the large object. So not touching, not touching. Now we're touching, and then we're not. One more time. Touching, and now we're not. So that's half of the solution. Obviously we're not actually touching because we're above it or below it, but we're only dealing with left and right now, so we just need to add two more clauses to this very complicated if statement. So we're talking about top and bottom. Then if the bottom is greater than the top, the bottom of the small one is greater than the top of the large one. So thing.rect.bottom is greater than other thing rect top. That'll take care of there. And then finally we want to do thing rect.top is less than other thing rect.bottom. So we're not touching anywhere around here. We're not touching, and then we're touching. And we're not touching. And we're touching. And we're not touching. Touching and not touching. So that should hopefully demonstrate the whole process. Again, the math is simple. The logic is simple. It's just this number is greater than that number, or this number, and this number is less than that number. There's a bunch of numbers, but it's really hard to keep it organized. That's why I like having methods on the two objects that organize a lot of the numbers for you. And remember that when you're setting up the bounding rect for a circle, it's a different formula than setting the bounding rect for a rectangle. And remember also that in Flappy Bird, you're actually going to be testing against three different things. You're going to have the top pipe, which is a rectangle, the bottom pipe, which is a rectangle, and the ground, which is also a rectangle, but you can actually just think of it as just a top edge because you don't even care about the bottom edge. And it stretches from left to right, so the left and all the way from left and right, so the left and right edges don't really come into play. So that's the whole process. You're just going to expand upon this. You can have multiple functions saying bird is touching top pipe, bird is touching bottom pipe, bird is touching ground. And if any of those things happen, you're going to change the game state so that it's no longer playing, that it's lost, and you'll draw something different at that point. So that's a lot, but that's why I do these in screencasts, so that hopefully you can rewind and watch a couple different things over and over again. But obviously, ask me questions, email me, use the share function in Cloud9 to send me your project and let me know what's not working, and I'm more than happy to help. So, good luck.